Let's go over limits part 7. In this video we're going to be calculating different limits. So limits part 7, calculating limits. So we'll start out with a theorem and say suppose the limit as x approaches a of f of x equals L, the limit as x approaches a of g of x equals M, and c is a constant. And a constant is just a number that is always the same. So c could be equal to 3, c could be equal to negative 17.5, it could be equal to the square root of 5. It's any number that just stays the same all the time and it doesn't change. Then the following hold true. If this next part is a little bit confusing for you, don't worry about it. Until you're used to reading more complex math, a lot of this stuff really does just seem like general abstract nonsense, but we'll go over some examples to hopefully clear it up. So we'll say limit as x approaches a of f of x plus g of x equals L plus M. We can say that same thing except with subtraction. So limit as x approaches a of f of x minus g of x equals L minus M. We can do the same thing with multiplication and division. So limit as x approaches a of f of x g of x equals L times M. We can say the limit as x approaches a of f of x over g of x equals L divided by M, assuming that g of x, that looked messy. Assuming that g of x is not equal to 0 and M is not equal to 0. And the last thing we can say is a thing about constants. It's that the limit as x approaches a of c times f of x equals CL. Let's go over some examples to show what exactly this means. This is just rules for showing what we can and can't do whenever we calculate limits. So we'll go over example 1. Let's say we're given that the limit as x approaches 5 of f of x equals 7, and the limit as x approaches 5 of g of x equals 8. We'll find three different things. We'll find f of x divided by g of x. We will find, let's do 2f of x minus 3, and we'll do, g of x times f of x minus 4. So for this first one, f of x equals 7, so we'll have 7, and then we also have g of x equals 8, so it's 7/8. So our answer is 7/8 for the first one. For the next one, we have 2, which is a constant. The order of operations stays the same. F of x equals 7. So 2 times 7, and then we're subtracting 3, which is the same thing as 14 minus 3, which is 11. And then our final one here, the final thing we want to find is g of x times f of x minus 4. Well, g of x is 8, f of x is 7, and we're subtracting 4 in the order of operations, which is 56 minus 4, which is 52. For our next example, we're going to do something a little bit different than normal. Let's say that, well, example 2. Let's say we have the limit as x approaches 4 of x equals question mark. Well, the limit as x approaches 4 of x equals 4. Or more generally, we can make a pretty common statement about this. That's a specific case of it. We can say that the limit as x approaches a of x equals a. So anytime a is going to something down here, if we have just that letter and not f of x, so we're not putting into any kind of function, it's whatever this number is down here is our answer. Well, similarly, we can say a little bit more. We can say that the limit as x approaches 4 of x squared equals 4 squared, which is 16. That's from one of our, because here x squared is similar to our f of x. Instead of having x here, instead of having f of x, we're just writing x squared in, so that's where f of x is. So here, f of x equals x squared. And more generally, we can say that the limit as x approaches a of x squared equals a squared. Let's do one more example. Let's say that we have, well, example 3. Let's say we have the limit as x approaches 4 of 5x cubed. And we want to calculate this. Well, we just plug 4 into x. So 4 times 4 is 16, and 16 times 4 is 64. So it's 5 times 64, which is equal to 320. So the limit as x approaches 4 of 5x cubed equals 320.